Your cache finds a 94% similarity match. Great, except the cached answer is a US return policy and your user is in India. Same question, wrong answer. That's the problem with naive semantic caching, and today I'll show you how to fix it. Semantic caching stores LLM responses and reuses them when a new question is similar to a previous one. It saves cost and latency, but the naive approach, just check if the similarity is above a threshold and reuse, has a dangerous blind spot. High similarity does not mean safe to reuse. Here are 5 ways a naive cache silently fails. Different person. Where is my order is user specific. Serve one customer's order status to another and you have a privacy breach. Different place. A return policy valid in the US might be completely different in India. Same question, different regulation, different entity. Can I return this laptop and can I return this jacket are nearly identical sentences, but electronics might get 30 days while apparel gets 14. Different time. A cached answer from last week becomes misinformation if the policy was updated yesterday, and different intent. Cancel my order is an action request. What is your cancellation policy is a question. An embedding model sees them as similar. They require completely different handling. The core principle, use similarity for retrieval, not authorization. The vector search proposes a candidate. A deterministic safety gate decides whether to approve it. 6 checks run before any cached answer is returned. Scope, is this public or user specific? Intent, is the request informational or an action? Location, does the geography match? Entity, do the product categories or constraints align? Freshness, has the entry expired? And risk, does the similarity meet the threshold required for this sensitivity level? Hard filters run first. Only if every check passes does similarity matter. In practice, every cache entry stores not just the question and answer, but the conditions under which that answer is valid. Intent, scope, country, product category, expiry date, and policy version. The decision function checks each condition in order. Scope mismatch, reject. Intent mismatch, reject. Wrong country, reject. Entity doesn't align, reject. Expired, reject. Similarity below the risk-adjusted threshold, reject. Only then, approve. The key design decision. You never average away a privacy or policy mismatch with a high similarity score. If you're building this yourself, start with a naive cache, create failure cases that break it, attach metadata to every entry, add hard filters, calibrate thresholds per risk level, and log every decision including wrong reuse incidents. Remember, the safest cache miss is cheaper than a confidently wrong cache hit.